Good day, everyone. So today we shall be looking at an interesting topic, which is motion in mechanical system. Motion is a very fundamental concept in nature and in engineering, and it is defined as the change in position of an object. Okay, it is applicable in celestial body and intricate machine component. So we shall be understanding what motion is in mechanical system. So first of all, let's talk about the type of motion we are looking at today. There are different types of motion, but basically we are going to be looking at these two types. The first one is called the linear motion. This motion involves change in position of an object along a straight line. So whenever there is a change in the position of an object along a straight line, then that motion is tagged linear motion. On the other hand, if there is a change in position around the fixed axis, then we refer to that kind of motion as rotary motion. These type of motion are very, very key in mechanical system. So then, let's talk about the linear motion in detail. We have just said that linear motion is a motion on a straight line. Now, there are different machines that perform this kind of motion. Number one is the lever. The lever is a simple machine that helps us to perform our work easily. Imagine that you get a nail and a hammer, and then you hit the nail inside the wood, and suddenly realize that it was the wrong place. What do? You need to pull it out. The hammer might not be able to pull out your nail, so you will need a machine known as the crowbar. The crowbar is a type of lever because it has a fulcrum at the point where it can turn. Look at it here. To the point where it can be turned around is known as the fulcrum or the pivot. Now, this pivot is the point that touches the wood. Then there's another place called the load portion. That's where the nail will. That's where the crowbar will pick the nail. You see here, and then the effort here, where there is human hand, that's where the effort is applied. Now, when the effort is applied, okay, the fulcrum turn, and then the load part picks up the nail out. So without the turning of this fulcrum or pivot on the table, you will not be able to pull out this. So with the help of the fulcrum in this program, it makes it easy for this man or this person, a man or woman, to pull out this nail, okay, making the work easy instead of using his hand to pull out the nail, which might be impossible. So now, what are we talking about? The lever exhibits linear motion because as the force is being applied by this hand, the nail begin to move upward in a straight line, and then we say that's a linear motion. Another example of linear motion is the use of linkage device. The linkage device is just assemblies of metallic bars connected by elbow or sliding joints. As you could see here, when you have different bars that are joined together at different ends, then the whole connection is called linkage. Now, what happens in linkage is as this bar here is moving front and back on a straight line, the other bar move up and down on a straight line, and then the third bar here move back and forth also on along a straight line, exhibiting linear motion. So these are the typical examples of machine that exhibit linear motion. Then on the other hand, the second type of motion, which we call the rotary motion, also has different types. Okay, we have said that it's a motion of an object, okay, in a circular form around a fixed axis. So we have two types. So we have the one-way rotary motion and we have the non-return rotary motion. Now, for the one-way rotary motion is a type of continuous rotation that only stop when brake is applied. The type of continuous rotation or circular motion that only stop when you apply brake is referred to a one-way rotary motion, and we can easily find that in our analog work clock or wristwatch. Those wristwatch that do not have digital type, that you have the 1 to 12 being numbered, and then you see the second arm moving in the rotary motion. So this is called the one-way rotary motion because it can only stop in its own case when the battery is down. The second type of rotary motion is called the non-return rotary motion. Still, the object is moving in a circular form about the axis, but this time around there is intermittent movement. It stops a little and it keep moving in that one direction, but it will be stopping gradually. So motion stops and continues at intervals. That would be my intermittent. Unlike this one way, the motion do not stop. The only time it will stop is when there is a break. Alright, so these are the two types of rotary motion we have, the one-way rotary and the non-return rotary. So how do we control rotary motion? We have mentioned that there are two types of rotary motion. So whether it is the one-way rotary motion or the non-return rotary motion, we need to control this motion, and there are devices that can do that. The first one is called the brakes. The brakes perform the same function wherever it is being applied. We know that in a car, when there is a sudden crossover by a pedestrian, or maybe the vehicle in front suddenly stop, the one coming behind will need to apply a brake to prevent accident. So what the brake does is to slow down or completely stop a moving body by removing the kinetic energy. So the function of the brake is to stop a moving body. So one of the ways to control a rotary motion so that it could stop or to avoid so that it will avoid accident is to use brake. Another device that can be used is called the clutch. We can find both the brake and the clutch in a vehicle. Now what the clutch does is to connect and disconnect two moving parts, okay, allowing for control power transfer. So in its own case, there are two moving parts for clutch, but it does connect and disconnect them. Okay, it connect and disconnect, reconnect again and disconnect, so that it can have controlled power transfer. If that connection and disconnection does not take place, the power transfer can lead to accident or damages. And then the last device that can be used to control rotary motion is called the ratchet. What the ratchet does is to transmit intermittent motion or allow motion in only one direction. So it performs two purposes. One, it allows motion just only in one direction, and number two, it allows intermittent movement of the object in rotary motion. So let's talk about the brake now in details. We know that the brake is used to stop completely movement. Now there are different types of brake. We have the disc brake. We use this brake for light vehicles. Okay, as you can see, this is a typical tango of a disc brake. How does it work? So the disc brake use caliper to squeeze pad against a rotating disc. All right, so this is a rotating disc here now. This rotating disc. Now, when there is a squeezing here, as you see this person pressing this. Now, when there is a squeezing here, like when there is pressure being applied there, what happens is that some fluid goes through this pipe, and it goes and stop that rotating disc. Okay, and once that rotating disc stop, definitely stop this tire. That's how brakes work in a vehicle, especially the one we call the disc brake. It's called disc brake because the disc is being stopped by the caliper. This thing that is being pressed is the piston, and the caliper is what is pressing down the disc here. Okay, so when there is a piston, when there's a pressure from the piston here, you send it to the caliper that now send it to the disc and stop it from moving. So this is how the disc brake works. Once the disc stop moving, then automatically stop the tire from moving too. But there's a link between the two of them. So we also have another type of brake called the drum brake. We use this for heavy vehicles. We have the external block brakes too. We use it for cranes and winches. Then we have the internal shoe brake. We use the type of brake for motorcycles and small automobiles. Alright? Then can we now talk about the clutches? We have said earlier that the clutches is made for connecting and disconnecting. It is used to connect and disconnect so that it can control the power that is being transferred. So clutches enable the controlled engagement and disengagement of power between rotating shafts. So it connect and also disconnect. And we have two major types. We have the friction clutch. In friction clutch, it makes use of friction to gradually engage power and to prevent sudden jab. Look at it here now. So remember that we said it is used to enable controlled engagement and disengagement of power. Look at these two rotating shafts now. This is one here, and the other one there is rotating. Now this is the clutch that is moving this rotating shaft forward and backward. Now when you move it backward, you find out that there will be a stopping here. So watch now. So when it goes uh, when you have a connection, there's a rotation. But when you pull out, it stops working. That's what we call the disconnecting and the connecting um, function of the clutch. So this is how the friction clutch works. The same is similar to that of dog clutch. The dog clutch also provides a positive non-slip connection often used in heavy-duty application. Just the same phenomenon or the same procedure. The only difference is the design. For the dog clutch, you could see that the two shafts are designed differently. Unlike this, that they are complete circular in design. So the only difference is just the design. Now it moves back and forth to disconnect and to reconnect. So with that, it's going to be controlling the transmission of power between the rotating shafts. You could see these two rotating shafts, the silver one and the other color. So this is how the clutch operates. All right. Lastly, let's talk about the ratchet, another device that we use in controlling rotary motion. The ratchet is a device that is used for controlling unidirectional motion and prevent reverse movement. So it does two things. It helps in maintaining one direction, which we refer to as unidirectional. It helps in maintaining one directional motion, and it also helps in intermittent motion. That is, it helps in stopping and starting the motion at interval. Okay, this is the typical image or video of a ratchet. You could see it can only turn in this anti-clockwise direction, but then this spring here is altering the movement intermittently. As it's dropping on it, it reduces the speed, and as it lifts up and as it moves out away from it, it allows it to move. So that's what we refer to as the intermittent movement of the object in rotary motion. All right. So what are the area of application of this? Before we talk about that, let's look at how to convert rotary motion to linear motion. We have just said there are two types of motion that we are discussing today, the rotary and linear. Now we can convert rotary to linear, and there are devices that can do that. Number one device is called the rack and the pinion gear. For the rack and the pinion gear, it has two objects. It has the gear, the circular gear, and it has the rack with its teeth. So the rack is moving in linear motion while the gear is moving in circular motion. So this is how rack and pinion gear convert rotary motion to linear motion. So as the gear is moving in a rotary manner, it is moving the rack on a straight line, which is the linear motion. Another device that can convert rotary to linear motion is called the crank and slider. The crank and slider. So this also transforms rotary motion into reciprocating linear motion. You could see as the crank is moving in a rotary form, you could see that there is a linear movement of the slider here, back and forth. That's what we call the reciprocating linear motion. So there is a back and forth movement of the slider due to the rotary motion of the crank. So that's another device that converts rotary motion to linear motion. And lastly, the screw mechanism. There are so many devices that make it of this mechanism: the screw jack, the bench vices, even the G-clamp. But look at the typical diagram of it. This is screw jack. So as this handle is being rotated, it's increasing the size of the screw upward. So this is moving on a linear motion vertically upward, while this is going in a rotary movement. So as it's being turned in a rotary movement, then the body of that screw jack begin to move up in a vertical manner. So this is typical example of how rotary motion can be converted to linear motion. So lastly, we're now looking at the application of these devices, or this motion rather. So number one area is in the application of tools and equipment. We have been talking about them. We just talked about one now. That is screw jack for lifting vehicles and other heavy material, heavy object. Now this is another one. This is the drilling machine. The drilling machine is used for making holes. As we are seeing here now, as this drill is rotating, it's also moving in linear motion towards the wall. We see it's moving on a straight line, but it's also rotating. So rotary motion is being converted to linear motion, which help in creating holes here using drilling machine. We also use this mechanism for car brake. We talk about brakes, we talk about clutches. So we use it in brake, for cars, for motorcycles, and other transports. Alright, so this is where we shall be drawing our curtain today on application of motion in mechanical system. I hope you have learned something today. Thank you for watching and have a wonderful rest of the day. Bye for now.